All right, problem 2-39. Make predictions about how many places the graph of each equation below will touch the x-axis. You may first want to rewrite some of the equations in a more useful form. Okay, one of the things that's going to make this easier for us here is if we try to get our equations into our factored form. Remember, factored form there, that's just when we get it factored into y equals a times x plus b times the quantity of x plus c. Remember, this allows us to use the zero product property when our y ends up equaling 0. So we're going to be trying to figure out how many different factors we have when our y equals 0. So for instance, let's look at A. For letter A, we have y equals the quantity of x minus 2 times the quantity of x minus 3. Now, if we want to figure out where it's crossing the x-axis, let's go ahead and put 0 in for y. And we'd have x minus 2 times the quantity of x minus 3. And this is where we would use that zero product property. We would say that x minus 2 equals 0, and x minus 3 equals 0. So we would get that x equaled 2 and x equaled 3. So in this case, for A, we would have two different places where our graph would touch the x-axis. So we have two unique points, we could say. We'd be crossing at 2, 0 and 3, 0 for letter A. That's a 0 there. Okay, so if we looked at B, if you looked at that one there, this one right now is in what we would consider to be vertex form, but if we could also consider it to be factored form if you looked at it there. If we looked at B and we thought about it as y is equal to the quantity of x plus 1 times the quantity of x plus 1. In which case, when you plugged in your 0 and you had 0 equals the quantity of x plus 1 times itself, how many answers are you going to get? Or how many different answers would you get? In this case, it's just going to be 1, right? You're going to get one answer. So you're going to get x equals -1 when you do it. So in this case, notice there, we have two factors, but it's the same factor. So we get one time that it's going to touch the x-axis. So it's going to touch the x-axis one time. And if you think about it, if you remember, our point there is going to be -1, 0. It's going to be what we call a double root because it repeats itself. Okay, when we look at C, letter C, right now we're in standard form, and we need to go from standard form to factored form. So we're in standard form, and we want to go to factored form. So when we take our y equals x squared plus 6x plus 9, you'll notice there, this one is a perfect square trinomial. So when you factor it, and I'm going to go ahead and factor it there. If you need to take a second and pause it and factor it, do that. But you're going to see that you're going to get x plus 3 squared, or x plus 3 times the quantity of x plus 3. In which case, you know that when you solve that, when you set them equal to 0, as we did up in the first one there, you would get x equals -3. So this one's going to only end up touching one time as well. Okay, that point where it's going to touch the x-axis is going to be the point -3, 0. And this one's also going to be a double root. So right now we've got this one. I'm going to just go ahead and change that there. Let's just say it's going to touch 2 times. This one is just going to touch 1 time. Letter B just touched 1 time. So I want you to start kind of looking at the ones that touch once versus the ones that touch twice. See if you can figure out the pattern why these ones are just 1. Let's look at D. I'm going to move over here. I know it's probably not normally what you do, go from right to left, but it'll be fine, trust me. We have y equals x squared plus 7x plus 10. Now when you factor that, or actually let's set it equal to 0 first and factor it as we're doing it. So we're going to end up with x plus 5 times the quantity of x plus 2. So how many different factors are we going to have? Well, we're going to get 2 different factors. So we'd end up with x would equal -5 and x would equal -2 after you set them both equal to 0. So in this case, we end up with 2 times it's going to touch. Or 2 locations this will touch there. It'll touch at -5, 0. And it'll touch at -2, 0. And if you're not sure on any of them, you can go ahead and just get out your graphing calculator and graph it to see if you're right or wrong. Let's do letter E. Letter E, we have another one in standard form, so we're going to go to factored form on this one as well. So we're going to say here that y equals x squared plus 6x plus 8. So let's factor it again like we did with C and D. I'm going to go ahead and change it to 0 because we're trying to figure out where it crosses the x-axis. This should factor into x plus 2 times the quantity of x plus 4, in which case we have 2 different factors again. So x would end up equaling -2, or x would equal -4. So we're going to say this is going to intersect 2 times. And our points are -2, 0 and -4, 0. And f, let's look at f now. Another function in standard form. We have y equals the opposite of x squared minus 4x minus 4. When I take it and look to factor it here, first thing I'm going to look at here is I'm going to factor out the negative. So when I factor out, it's like factoring out a -1. -1 times x squared gives me -x squared. -1 times positive 4x gives me -4x. And -1 times a positive 4 gives me a -4. So all I did was basically pull out those negative signs, and they ended up right here. Now this still factors. It's a perfect square trinomial, so we should get y is equal to the opposite of x plus 2 times x plus 2. And you'll see now that's the same thing here. If we put our 0 in, we're going to have 0 equals the opposite of x plus 2 times x plus 2. If you were to solve this, you would get that x equals -2. So this one is only going to touch the x-axis 1 time. Now all of these points that only touch one time, I'm sorry, all these graphs only touch one time, you have to think about it. How could a parabola only touch the x-axis in one place? What point does that have to be? In this case here, we call that a double root. But all these ones here where it touches just once, okay, remember that's got to be the vertex. That's going to be the vertex. And you can go ahead and check it by graphing it on the calculator. We'll graph a couple of them here just to show. Let's do x minus 2 times the quantity of x minus 3, just to show an example of how to check it. I'll let you check the rest on your own. X minus 2 and x minus 3, we graph it. And you'll see there, oh, it looks like it may only cross at one place, but let's zoom in a little bit. Let's start out with our standard zoom, and you'll see it does cross underneath. Now you can zoom in closer if you use your zoom box. That's number 1. Now you're going to move your cursor to where you want to zoom into. So move it up to like a corner, press enter, and then you can press down. And what it's going to do here is going to draw a box, and it's going to zoom in exactly to where that box is. So let's press enter the second time there, and you'll see it does cross at 2 and then 3. So we have x-intercepts at 2 and 3. This one here, x plus 1 squared, see x plus 1, that quantity squared. Let's do zoom 6 to start out. See, it looks like it's only going to touch one time here, and that's exactly right because this is our vertex. This is what we call a double root. Double root right here. So all these ones here that I'm underlining in red, this is where the vertex is on the x-axis. So that one, this one only touches once there. That means it's the vertex, and you can go ahead and check that and see. And we've got one here where this vertex touches it there. So I'll let you finish checking those because I don't want to make this too long. We're almost up to 13 minutes already. Letter H, write a clear explanation describing how you can tell whether the equation of a parabola will touch the x-axis at only one point. Well, remember, we're looking to see, is it a double root or not? Does it have the same factor repeating itself? If it does, that means that what we have is a perfect square trinomial. So if we wanted to write a quick statement there, we could say, when the vertex is the only point on the y-axis, I'm sorry, the x-axis, the equation is either a repeated factor, like in B, we'll say a factor squared, or a perfect square trinomial. Basically, we're looking for when we have multiple factors, we have multiple x-intercepts. Okay, so we're looking here. We see the same factor, so we know that this one is going to end up being the vertex. This one here, we know it's going to end up being the vertex. This one down here, we know it's going to end up being the vertex. All the other ones there's multiple factors, so we have multiple roots. All right, this is problem 2-39. If you have questions, make sure you still ask your teacher. Otherwise, thanks for watching.